Alright, hello everyone, this is your trainer Venkat, and today we are going to see variables, data types and operators. In my previous videos I've covered history and evolution of Java, where it was module 1 where I've covered the features, the evolution over the past years, and also we have covered high level features of Java. Now in this module 2 we are going to cover what are primitive data types, operators, and what is about type conversion and casting. Alright. Now, one thing we need to remember, like before writing any Java program or before writing a single line of logic or before writing any loops or anything, you need to remember one thing. It all starts with data types. Why so? Because Java is a strongly typed language. That means when you create a variable, you'll not say that, hey Java, store this thing. You'll tell Java exactly what kind of thing it is. Like it is a whole number or a decimal or a single character. Or for the case it is a boolean value, true or false. So Java wants to know upfront. So as you can see, there are 8 primitive data types provided by Java, which are byte, short, int, long, float, double, char and boolean. Now, as you can see, we have also provided what is a description in terms of bits and also the range of each primitive data type that can be referred in this slide. Now overall, if you see here, if you want to store a large numbers, for example, if you want to store a big values, for that reason you will be going for int. As you can see, the range of int is minus 2.1 to plus 2.1 billion. In the same way, when you want to store bigger numbers or larger numbers, we need to go for long. And where do we use long? For bank balances, timestamps or gigantic population numbers. Now moving on to decimal. For decimal, we have two things which are float and double. So float and double, which is a 32-bit decimal and a 64-bit decimal. It all differs how do you store the value. For example, if you want to store a variable which is 9.99, Java treats this as a double by default, not a float. So if you write a float price as 9.99, your code will not compile. For writing a float price, you need to write float price 9.99f. You need to append that small letter f to make sure your compiler identifies it's a float value. And similarly, we have char, which is for the characters, which are individual characters. If you have to store individual characters, which are 16-bit Unicode, which are in the range of single character, then we go for char type. And finally, we have boolean, which is a 1-bit, which can store true or false, right? Now, moving on to operators, Java provides overall 6 operators: arithmetic, relational, logical, assignment, bitwise and ternary. Now, if you have to distinguish all these operators, remember these operators are also important, which are playing a major role for the building blocks of Java. So basically, arithmetic is for the numbers where you have different operations. Then you have relational, where you want to know which number is larger, which number is lesser, which is equal, which is not equal. Then we have logical operators, which are using and, or, and not. So that is based on a truth table using zeros and ones. Then we have assignment operators, where equal to is appended with plus, minus, into, division or modulo division. Then we have bitwise operators, which are single and, single or, not, XOR, left shift, right shift. We'll see some more when we do the programming. And finally, we have ternary operator, which is based on a condition. If condition is true, then value 1 will be executed, else value 2 will be executed. Then we have type conversion and casting. So type conversion, sometimes you need to take a value of one type and use it as another. So Java handles two scenarios here and they work very differently. As you can see, widening is also called implicit. It is an automatic. That means we are going for a smaller type to the bigger one. So here, byte to short or short to int or int to long, long to float, float to double, right? And then we have one more concept which is called narrowing, which is explicit, where you want to store a bigger value into a smaller value, and there we need explicit typecasting. So when you want to convert double to int, then you need to typecast explicitly. As you can see in the example, int x is equal to, you're typecasting the right side value 9.99 to integer, because in this case we are converting double to int. And finally, when you see the value of int x, it gives only 9 because the remaining decimal values is truncated. Because using this narrowing or explicit typecasting, sometimes we result in loss of values. This is a basic example. Now, moving on to the next one, which are control statements and writing your first Java program. Now, as you can see on the code, we have a program which is a base program, public class hello 1 lakh. Then we have public static void main, string array of args, system.out.println hello, comma Java world. So the basic keywords used here are public, class, static, void, new, this, super, return, extends, implements, right? Import, package, interface, abstract, and final. So the basic keywords that we have, key keywords that are used in programming are these ones. But you have to observe the program which is defined as public class hello 1 lakh. As you know, everything is stored inside a class in Java. So that means if you have to store any variable or write any method, you need to store inside a class. Then we have public static void main, which takes string array. It takes an array as an argument. So that means it's a method which is a main entry point. That is where you trigger your entry point. Now, in this code of public static void main, the most important line, this is the most important line you will write in Java, because this is an entry point. Java scans your entire program looking for this exact signature. No other method name works or no shortcuts. If Java finds it, your program will run, otherwise it doesn't. And then we have a line called system.out.println. What does this do? This will send a line of text to your console. The ln at the end means it adds a new line after printing the value. And if you drop the ln, use just system.out.print, and the next print statement continues on the same line. This is a small difference, but a big impact when you are formatting the output. Now let's talk about the different control statements that we have. Basically, the control statements are divided into three categories: conditional, loops, and jump statements. Remember, we are going to cover in our Java programming. When we touch base the Java programming, we are going to cover the practical usage of these three control statements. Under conditional statements, we have if else, else if, where if a condition satisfies, whatever that is present inside the if condition, that will be executed, else the else part will be executed. So similarly, we have if else, and else if as a basic conditional statements. When the if else conditions increases, it is always good to use a different conditional methodology which is called as switch case break default. So switch case is used when you have multiple options. You need to choose one out of the multiple options. Then we go for switch case. This is also we are going to see in a programmatic approach. And finally, we have ternary operator, where when we execute a ternary operator, if it satisfies, the one after the question mark will be executed, else the value after the colon will be executed. Then moving on to the loops, we have three types of loops given here: for loop, while, and do while. Remember, for loop is nothing but when you know the number of iterations to be iterated. When you say iterations, those are nothing but number of times you need to repeat the logic. So when you know that this is the number of times I can repeat my logic, then we go for loop. When do you use while loop? So while loop always checks the condition first. When you want to keep going until a condition becomes false, but you don't want to know in advance how many rounds that will take, then reading lines from a file until you hit the end, this is a good example of using a while loop. So that means the overall summary is while loop, it checks the condition first, then only it enters into the while loop. Then we have do while. So the difference between while and do while is that in while you check the condition, then only at least one statement will be executed. Whereas in do while, you can execute a statement, but the condition will be verified after that statement at the end. Right? If the condition satisfies, it will iterate, otherwise it will come out of the loop. So this means do while executes at least once. Do while executes at least once. Now, moving on to the next one, which are jump statements. So jump statements are basically when you want to come out of the loop. The first one is break. It says you can exit from a loop or a switch. When you use a programming like for loop or a while loop, if you want to come out of the loop at a particular instance of time, you can use the keyword break. The second one that we have is continue. Continue says you continue the program by skipping the current iteration. Current iteration is nothing but the current flow that you are executing using a for loop or a while. Then we have return method. Return is nothing but that is an exit part of your method. When you say return, that will execute or the exit method from your programming. So this is the about the control statements and the first Java program. Moving on to the next one, which is methods and arrays. Now basically two things they are there on the slide. Both of them are absolutely everywhere in Java code, right? So methods and arrays are very important when you write anything inside the programming. Now if you observe the method int add, you have two parameters as input, int a comma int b. Then when you open the brace, you have written a plus b. So what does this add method do? It will take two parameters which are of both integers. It will execute a plus b, which is an addition, and it is returning. So this method returns an integer. So that is the reason you have int add. So int indicates the return type. And definitely since you have a return type, you need to use the return keyword a plus b. If you observe the overall structure, we have method declaration and return type and name params. In the place of int, if you keep void, it means no return value. Then there is a concept called method overloading. It means you have the same method, two methods of same name, but different input params. So sometimes you have int add. In one method you have int a comma b. In the other method you can use any other data type. So that is nothing but overloading. Same name of the method but different parameters. And these parameters are passed by value. Right? These parameters are passed by value. Then we have arrays concept. So arrays concept is nothing but you are storing a collection of elements. You're storing a collection of elements, right? So array is a fixed size container that holds multiple values of same type. This is a very underlining point. So that means you are defining a fixed size container that is holding a multiple values of same type. So when you say int array space nums, which is a variable equal to 10, 20, 30, it means it is an array of type integer, right? So three integers, one variable, 10, 20, 30, three integers and one variable which is nums. And here's the rule that never changes. Indexing in array always starts at 0. Always. When you say indexing, nums of 0 it stores 10, nums of 1 it stores 20, and nums of 2 it stores 30. There is no nums of 3 because your indexing is starting from 0. And length of the array is calculated by using array.length. And if you have to iterate through the elements of an array, what you need to use? You can use a for loop here. You can use a for loop or a for each. The best suitable loop for iterating through elements of an array is for each loop. You can see the syntax for int x colon array. Int x, each array element is of integer type, and arr is a collection, which is a representation of an array. And if you want to declare a multi-dimensional array, which is like int array grid is equal to new int 3 by 3, which means it's a multi-dimensional array of size row by column grid structure. Suppose if you have to declare int 3 by 3, it is a 3 by 3 array. It's a multi-dimensional array. And if you need to visit every element in this multi-dimensional array, you need to use for loop. So for loop is a very clean option you need to read from the array. And if you have for int x colon arr, it means for each integer in arr, which is a variable. So there will be no index variable in this particular syntax and no bound checks. Very clean, readable for iteration through every element. Right. So this is about methods and